Hello, and welcome to Suffolk Public Library's Chesapeake Requiem programming. I am joined here today by Associate Professor of Geography, Michael Allen. He is at Old Dominion University, and Professor Allen will be speaking to us today about climate change and its implications on public health. Thanks for joining us today, Dr. Allen. How are you?
Good, thanks, Matt. I really appreciate Suffolk Library for hosting, particularly given the pandemic and COVID and the online environment. But I'm happy to any questions anybody has as we proceed to feel free to shoot me an email anytime to answer any questions.
Oh, that's great. So I understand that you have a presentation prepared for us about your work on climate change and health. How are the two related?
Yeah, great question. So the CDC and a lot of the health professionals highlight climate change as what they call a medical emergency. And when I'm talking about these issues in class or in the community, I often use the analogy of if you cut your leg off, right? That's an emergency. You need to get attention soon or else there's significant ramifications. And so the CDC highlights, extreme heat waves, sea level rise intruding on sewer systems, introducing nutrients into waterways, which has an impact on marine environments, right? Human health is related to environmental health, and human health is related to the health and wellness of ecosystems by and large. So ensuring a healthy ecosystem and healthy planet ensures our health and well-being as Homo sapiens. So there's a lot of connections across those landscapes.
All right. Well, I'm very excited to see what you have prepared for us. Sure. Take it away, Dr. Allen.
Thanks again. Troubleshoot. Share. All right, so I think we can see this slide now, and this is the image that was kind of highlighting from the CDC and the health professionals, the wide range of impacts of climate change. I'm not going to talk about all of these, of course, right? A lot of my research focuses on heat health and the like. You can think about forced migration. Some places are becoming unable for human population to thrive in, whether that's because of sea level rise or extreme heat, asthma, respiratory functionality, new emerging diseases, because of our relationship and our interaction with different environments. So you can find this image online pretty easily, and you can see the relationships accordingly. When we talk about climate change, we're really interested in two things. One, we're talking about mean temperature. So today's weather is not indicative of the climate. So we're recording this on a day in which we receive snowfall here in Southeast Virginia, right? Pretty abnormal, but we do get snow occasionally, right? We have about an inch of snow a year on average over the last 30 years. Now, that means we might get 6 inches of snow one year and then not get snow for the next 5, and that's an average of 1. So means and extremes are relevant. But what we're seeing with a warming planet due to heat trapping gases being released into the atmosphere, carbon dioxide, methane gas, and the like, is we're seeing a shift of these, in this case, summertime temperatures. So a shift towards the right, more extreme heats. We still have cold, but it's less common. And it's also beginning to flatten the curve, if you will, and flatten the curve in the respect of the distribution is changing with respect to the mean. So we have this transformation that we're seeing on the planet. Often when I highlight this as a climate scientist, many people say, well, it's only a degree or two, right? Yeah, who cares, right? Summer, we get an extra 1 or 2 degrees in the summer. That's great. We can spend more time outside with our friends and families. But if your body temperature changes 1 or 2 degrees, you're probably going to go to the hospital. And if you change the temperature of ecosystems like the Chesapeake Bay or the environments by which oysters live and thrive in 1 or 2 degrees, those oysters aren't going to be there. They're going to move or they're going to die, right? And also, it's not just temperature, it's also things like pH or water acidity and the like. And so 1 or 2 degrees is pretty significant in terms of the grand scheme of things. On this as well, it's not just 1 or 2 degrees across the entire surface, right? We're seeing significant changes to our landscape in the Arctic region, melting permafrost, which is then exposing new vectors for disease and things of that sort. There's some new scholarship highlighting this in Russia and the like, as the melting permafrost is exposing dead organic material, which isn't necessarily advantageous for human health. So some of this is my research. The image on the right is from NOAA and the Global Change Program. What we know is that heat waves have become longer lasting, more frequent, and earlier occurring. So it's not just one of these, but it's a culmination of all of these factors. And we were talking earlier, Matthew and I, saying 2020 will likely become one of the coolest years of the rest of our lives. And if we think about, look at some of the statistics of the desert Southwest, Phoenix having over 130 or so 100-degree days, that's going to become more the norm than the exception. And Hampton Roads, since the turn of the 1980s, we've seen a doubling of our heat wave days. So there's significant ramifications, not only in terms of human health, but the green space that we have, the urban heat island. So the built environment becomes important. As a geographer, the intersections across the built environments, the human dimension, the environmental science, the climate science, it's a really interesting geographic lens to explore the world in. So some stories. Chicago, 1995. Maybe some of the viewers
remember this.
You remember this? Yeah. This is really the first big time stories in which heat was kind of at the forefront, right? We had hundreds of people dying in excess of what should be dying. So every year, every day, we have a certain number of people dying, but we are exceeding that significantly over a couple-day period in which our temperatures were abnormally warm in Chicago. Chicago, a major metropolitan city in a developed, quote unquote, developed society, right? Air conditioning, prevalence, and the like. A lot of people that died were elderly. A lot of the people that died were on fixed incomes. A lot of the people that died were in those old cinder block homes without any friends or family to check up on them, maybe having pre-existing health conditions, right? And we actually ran out of space in the morgue as a consequence of this heat wave. It's really an eye-opening event. Numerous books are written about this. Matt, I'm sure some of you, these books are actually in the library over in Suffolk as well. So this was really the first experience. Fast forward nearly a decade later, 2003. We don't hear much about this because this is not in the United States, right? But 2003, Europe, we had an unprecedented heat wave that killed between 50 and 70,000 people, because not only was it warm, okay, but this part of the world doesn't really have air conditioning. It's a Mediterranean climate. You open the windows, you look airflow, right? There's no need for air conditioning, assuming a static climate. Now, we need air conditioning now, particularly as this heat wave is becoming much more common, as I mentioned earlier. But not only was it hot, not only did it not have air conditioning, but you also had people flocking to the beaches, going on vacation, like you and I do in the summer, right? We're leaving mom and dad, grandma and grandpa at home without air conditioning, pre-existing health condition, and a consequence was as such. And this is really, those two events really pushed forward the research on heat. And what we know about heat is heat waves kill more people on average than any other natural disaster.
Oh, wow.
Which is, yeah, Matt, nobody I talk to knows this, right?
Yeah.
Kills more people than hurricanes.
Yeah, I would think hurricanes, right? Or earthquakes, maybe.
Earthquakes, flooding, yeah. Those events are really the wow events, right? You see a ravaged home, right? Horrific impacts associated with flooding in maybe New Bern, North Carolina, or what have you, right? But with heat waves, right, the local media, and this isn't a criticism of them, but they're showing somebody drinking water, right, sitting at the beach. And there are really interesting intersectionalities here with respect to heat, whether we're thinking about emergency room visits in Virginia or power failures on Hatteras recently. The last 2 summers, we've had power failures, not because of heat, but if you have a power failure and you're visiting and you need air conditioning, there are economic ramifications as well. So a little stuff, a couple things I've been working on with a colleague of mine, Dr. Jeremy Hoffman at the Science Museum. The image on the right are from him. The image on the left is from me. We actually did a citizen science, community science program in which we mapped the heat island. We drove around in our cars. There were about 40 volunteers aging from 7 or 8 to 80, right? Retired school teachers, little kids, parents, whatever. Drove around to the city of Norfolk. This is July of 2019. And we then modeled out what the thermal environment looks like. You see that in the left-hand side. Okay, fine, census blocks in the red. You see certain parts of the city are warmer than other parts because of green space, because of the built environment, right? Dr. Jeremy Hoffman on the right there, he did the same thing in 2017 in Richmond, and he then created heat vulnerability index in Richmond. And if you're familiar with Richmond, in addition, the neighborhood to the north here is relatively former industrial area, whereas the western part of Richmond is very green space, very white, right? And so there's a relationship to equity concerns here as well with respect to heat. And at the bottom, they mapped the ambulance call visits, which I think is an interesting kind of corollary between the built environment, the environmental condition, and a health outcome. He also, and you can read this in your own time, this is from the New York Times, the redlining piece to this. These communities that we're finding that are much warmer than the other parts of the city were historically redline districts in the 1930s. So land use policy from the over almost 100 years ago now is still manifest in 2020 and the ramifications that we have in terms of heat vulnerability. Mm-hmm. A really interesting, frustrating piece with respect to the climate health nexus. I like food, so we're talking about health and wellness, you know, about hospital admissions or mortality, but I like food. I love eating food, and I also love drinking beer, right? And to drink beer or to eat food, you need to grow food, right? Now, most of the food that we grow in America actually is used for exports or used for ethanol, feed for our cows or fuel for our cars. The breadbasket of America is kind of a nuanced, old approach. Most of that is not used for bread at all, but that's another story for another class. The Agalawa Aquifer extends from western Texas all the way up through parts of Nebraska and South Dakota. And what we're finding is that we're taking a lot of that water reserve from the underground aquifer and putting it on plants that we're growing. Now that sounds well and good, right? Well-intentioned. But there are certainly ramifications to a warming climate with the amount of water that we're taking out of the groundwater system in terms of the wellness of our food system. A colleague of mine who actually works at West Texas Weather Modification in San Angelo, Texas, says the amount of water that we're taking out of the Agalawa Aquifer every year will take about 100 years to replenish. That's a mind-boggling statistic.
Wow.
And so this idea of climate change will be beneficial for some plants. That's true. Some plants like poison ivy will thrive, but the food system certainly is not one of them. New pests being introduced as a result of warming climate, new disease, new pressures that exist. A little bit more close to home, again, we're talking about health. The image on the right is a ghost forest. Salt water is intruded into this.
This is saltwater intrusion, yeah.
Yeah, this is saltwater intrusion, Matt, exactly. So as the seas rise, saline water is introduced into the freshwater aquifers, and one is more dense than the other, as you might imagine. And so you basically push out the fresh water. And so there are some concern, places like the Northern Neck, Gloucester County, of salt water beginning to intrude, not necessarily for ghost forests, that's a challenge, yes, but more for like septic fields and septic systems. Because when you have water intruding into your septic system is no longer functional. And when your septic system isn't functional, that crap is going somewhere else, no pun intended. And it's going to the waterways, which is impacting aquaculture industries, it's a serious challenge that the Virginia Department of Health is actually really interested in, and other stakeholders as well. So just some examples of how climate is impacting indirectly our health. We can talk about direct and we can talk about indirect impacts, right? Heat waves are directly impacting our health and well-being, but these septic fields is an example of kind of an indirect. Another example of indirect health consequences are these toxic algae blooms that maybe you've heard of. It's tied to the nitrogen cycle.
And these are the dead zones?
Yeah, these are the dead zones, Matt. Yeah. So, and they're becoming a really good place to look at is the Great Lakes region because of the way the hydrology operates up there. But we do certainly have these issues here in Southeast Virginia in the Chesapeake Bay watershed, right? The Chesapeake Bay watershed is connected to places in New York, Pennsylvania, Maryland, right? Virginia. So all these states are feeding into, through the watershed environment, feeding into the Chesapeake Bay watershed. So what happens in Pennsylvania is impacting the watershed. And what we're seeing is a lot of the eutrophication, that's a fancy word for dead zone, Matt. The eutrophication that we're seeing is being introduced by runoff through agricultural practices because we're fertilizing our crops, right? Rather than rotating our crops like we used to do 150 years ago or so, through the three sisters mentality, right? Corn, soybean, squash, and all those kind of reintroduce the same nutrients. We get a lot of food at the same plot of land. No longer are we doing that. We're actually doing monoculture. And so we have to replenish those nutrients by fertilizing the soil. And that runoff has a double whammy. One, it's impacting the marine environment, but secondly, maybe more importantly, in some way, it's actually costing the farmer because they're losing those nutrients to the watershed. And so a lot of strategies, VIMS on the left there are Virginia Institute of Marine Science up in Gloucester, and then they have another location in Eastern Shore in Wachapree, Virginia. But they're really interested in modeling out and trying to prepare for what hypoxia is another word for dead zones, what that season may look like, particularly as we move forward by 2050, 2030, right? Different times into the future. This is a great graphic kind of illustrating our connectivity, both in the urban and quote unquote rural environments, right? Recognizing the world is not binary. But how do we go from a gray funnel that just takes water off the roads and dumps it into our watersheds to more of a green funnel approach where we filter water, it's allowed to percolate down through the soil, or recharges the aquifers. Let me go back one slide, two slides. The Eastern Shore actually sits on these aquifers here. If you see in the image on the left, this is the SWIFT facility. If some of your viewers are familiar, the Sustainable Water Initiative for Tomorrow over in South. Have you been there, Matt?
They are community partners of ours, and we had one of their engineers come and speak as part of the Chesapeake program as well.
Nice, cool. Yeah, I took my class over there maybe 2 years ago before COVID happened, and it was fascinating. But what they're doing is they're taking wastewater, they're treating it like you do with your fish tank, right? Your fish defecate, and they clean it through different filters, and they blast it with UV light, and then they clean it with another filter, and then they blast it with another type of light, and that cleans the water. And then they're taking that new purified water and injecting it back into the Yorktown aquifer. And that's it. And there's a couple of reasons for that. Is it's getting rid of wastewater, reduce, reuse, recycle, but it's also reducing our subsidence, which is a major challenge here in Southeast Virginia due to groundwater depletion and due to the physical geology, of our landscape actually sinking.
Yes, the land is sinking.
Yeah, so the seas are rising because of melting land-based glaciers, because of a warming climate, but we are also sinking. And that's why we have twice the global rate of sea level rise here in Southeast Virginia, about 15 inches since about 1930. And that curve that we've seen in terms of sea level rise, it's not a linear curve, right? It's a lot like the COVID curve. It's exponential curve. And so we're beginning to see through NASA observations and measurements that sea level rise is beginning to accelerate. So the linear changes of the last 100 years are not really reflective of what will happen in the remainder of our lifetime. So I guess in kind of a quick overview of some of the health ramifications. Again, we can go into more details about malaria and changing vector ecology of how new diseases are being introduced because they're finding habitats suitable to thrive in. That's one of the issues, I think, in Southeast Virginia. We have a lot of ditches and reservoirs for water, and that's all well and good to reduce flooding impacts. But those habitats are also habitats for vectors like mosquitoes. And a really good book, Matt, if you're looking for other readings, is now it's going to escape my mind, but it's about yellow fever and how Hampton Roads was one of the last places in the United States with a major yellow fever epidemic. And as a consequence, we used to think diseases were caused by miasma, bad smelling air. You can actually read early colonial writing in Williamsburg about people fleeing the fog to get into homes because they thought the bad smelling air was causing diseases. Diseases aren't caused by bad smelling air. We know that now. But at the time, we thought yellow fever was caused by bad smelling air. So we got rid of all the wetlands. We filled in all these landscapes. And in one way, we got rid of the habitat for the mosquito, but we have a lot of these ditches around. So the image on the right there, that's at Llewellyn, near Old Dominion University there. You can see the water. It didn't rain. It's a beautiful sunny day flooding. That individual should certainly not be driving through that water.
I think I've driven that way before.
Yeah, you haven't done that though, right? Margie Mulholland at ODU, she actually measures the muck. She's a biology professor at ODU, and she goes out with her students, even some high school students in Granby High School, I believe, and they measure the nutrients and the bacteria that is in that water. Because what's in that water? We have no idea, right? There's obviously pollutants from the truck SUV going through there, oil, slicks, probably fecal material from dogs, right? Pick up your dog litter. And so there's lots of ramifications with respect to a warming climate. Southeast Virginia is really interested in sea level rise, but health is certainly another major attribute here. And we know that humans are the primary cause. We know that the causes of climate change, yes, there are natural causes, but we cannot, as climate scientists, explain the changes over the last 150 years without taking into account the anthropogenic human causes, and that being heat trapping gases. So we can adapt to the consequences, but we also have to mitigate the causes by reducing those heat trapping gases. I talked very quickly. I'm happy to go back or anything, but I want to put this slide up just for your viewers if they're interested in chatting with me or connecting at any time. You can shoot me an email, mallen@odu.edu. And again, thanks to the Suffolk Public Library for hosting this seminar series and allowing me to be a part of it.
All right. Thank you very much, Dr. Allen. You know, this series was originally part of a number of events scheduled around an appearance by Earl Swift, who wrote the book, Chesapeake Requiem. Are you familiar with Chesapeake Requiem?
I am. I've read it, and I've been to Tangier a couple times. Yeah.
Could you recommend any books for someone in our audience who might be interested in learning more about climate change or how climate change might impact our health potentially?
Yeah, that's a good question, and the one I didn't think of answering. So there's a really good book that came out recently, and the name is going to escape me. And so let me see if I can find it.
We can always add it later in the comments.
Yeah, sorry. It's a great question. Here we go. Jeff Goodell, excuse me. The Water Will Come, Rising Seas and Sinking Cities. That's a pretty good one. And it's a pretty easy read, I think. And there's a new book that the title escapes me, that was just released. I have not read it yet, but it's out of Miami, and it uses Miami as a case study of mitigating some of these flood concerns, which I think is a big concern here, obviously in Southeast Virginia. In terms of direct health climate book, the book highlighting the 1995 Chicago heat wave, that's a good book, relatively easy read. And the author of that is Nash.
Mm-hmm.
And Eric Klineberg has also written one. That's probably a little bit dated now, although he had an update in 2015, I believe. But Nash was the one, and he's from Virginia, actually. And I can't remember his first name. But those are good ones. Nash talks about the heat, and the sea level rise, water will come by Jeff.
All right. Again, thanks very much, Dr. Allen, for your presentation, and also very generous of you to share your contact info. We'll be sure to include that in the published comments so that folks can reach out to you.
Thanks again, Matt. Appreciate it.
Thank you.